Hello, good afternoon, everyone. I hope you're having a good day. I'm Doha Saudi, a technical operations and support engineer, with my colleague Mirola Tadros, an associate technical operations and support engineer. Today, we'll walk you through our self-healing system, the road to 99.99%. Having a stable system is what customers are looking for, which requires high system availability and continuous monitoring, as a happy system means a happy customer. That's why we came up with the idea of having a self-healing system. Our agenda for today: why TechOps, traditional support system, self-healing system, use cases, test demo, and questions. TechOps stands for Technical Operations. It's not just a job, it's a lifeline to the customers, as they are responsible for maintaining your environment and make sure that your production is working by monitoring constantly its performance, both hardware and software. So mainly, the TechOps engineers are the valuable guys who make sure that everything is working as it should. That means customers need technical support as they are solving problems and making lives less stressful. So why TechOps? First, advice. Technical operations require having a huge lot of knowledge in different technologies, either used in the projects they support or in related technologies, that make them capable of giving the needed advice to the customer in all the layers in their system, as well as giving other teams advice regarding any action to be done on production, as they are the most involved team working on it and aware of almost every issue had happened on it. Information. A technical operations engineer can clarify any system operation from a business or a technical perspective if needed. Help. Most of the technical operations teams you may work with can be considered experts in the software they are supporting. Hence, most technical support service companies require their support technical operations to have some sort of certification on the product they are supporting. In addition, they work with the product all day, every day. Therefore, they can provide you with the needed technical information. Solution. The bread and butter of technical support is giving solutions. This is the main reason you use support. If you're in a pinch, they are there to bail you out. Finally, assistance. There is only one person or a small team that is responsible for resolving issues, implementing changes, working on technical aspects of a project, or any other task that may be assigned. A technical operations and support engineer can resolve any issue you're having, complete some of the tedious tasks that need to be done, or can assist you on the projects. This frees you up to work on the more important business projects and assisting other employees. From the above, we can say that the core of technical operations and support is easing the customer's work to achieve customer satisfaction. And as someone once said, I decided to go into technical support because I have been fascinated by technology all my life, and I also love working with people. I want to use my technical know-how to directly solve customers' issues. I want to be the person that makes life easier and more enjoyable for folks who have run into a problem. The traditional support system. A small performance issue takes place, for example, high CPU usage. But due to not figuring it out early, it aggravates till it causes system down. The minute the system goes down, the customer starts looking for help. And due to the system down, the customer gets extremely angry as his work hangs up. Then, the customer returns to the support agent by opening a ticket with the issue. The agent who received the ticket starts investigating each and every possible layer and reason that could have caused this down. Then, the agent finds out the root cause. He starts solving the issue and makes sure that system is up and running properly. Once the system is working fine, he replies to the customer that the issue is solved. Then the customer checks the system's performance, and finally, the agent keeps monitoring for a while till he's sure that the system is totally stable. So, which of the following is more of a disadvantage to you from the traditional support system we have mentioned earlier? The answers will be in the Q&As as A, B, C, and you should react to the one you see is suitable for you the most. Okay, so you have chose system unavailability. Okay, it's a major issue, I know, but let's go through the other disadvantages of the traditional support system, then decide which one is more of a disadvantage. First, issue exposure. As we saw in the previous example, a small issue can turn into a system down if not figured out early. So, instead of solving a small issue quickly, we spend a lot of time solving a major issue, such as a system down. Inform agent. It takes time going through the routine steps till the agent is informed to start investigating, which leads us to a time consumption. As on informing the agent, he goes through many layers trying to find out the root cause to start fixing the issue. From the last 3 points, we can see that a lot of time is taken to solve the issue. Meanwhile, the customer's work is totally obstructed. Then we have post-monitoring. The agent has to dedicate himself to monitor the system after solving the issue to ensure that the system is stable. This time could have been used to solve other issues or even gain more knowledge in any field. Finally, repetitive systematic work. Issues may repeat, so the agent and the customer both have to go through all the repetitive steps, from reporting the issue and to solving it and monitoring it, which is boring to them both when it's repeated. So that affects their psychological health, and by default, it affects their productivity. Now, after going through all these points, let's see what you think is the most annoying disadvantage of this traditional support system. You can vote the same way as the previous poll. Okay, so you have chose C and E. Time consumption. Okay, you've chose C, time consumption. And yes, it's a major issue. Time consumption can cause major system issues. As we have discussed it, a small issue can become a great one if we didn't find it early and just work on it to solve it. That's why we thought of an innovative support system that would avoid the disadvantages of the traditional support system. So in this system, we have monitoring sensors covering all the layers we have. These sensors monitor the performance of the system. So whenever there is an issue, it sends an alert. This alert fires the automation task, to solve the issue, and then it notifies the agent that there were an issue in a certain layer and it's solved now. All these steps take place in the background without any customer intervention, as the customer on the client side is working on the system that is working fine, as the issue has been solved before it caused any noticeable issues.
ميرولا سوري احنا بس مش سامعين الصوت كويس اعتقد انتي ميوتد.
مش هقول لا هي غلطة مطلعة. ماشي. Okay, so as we previously mentioned, from the traditional support system to an innovative system. The new system is named the self-healing system. So let me elaborate more on the concept of self-healing system. Let's face it, the systems are never perfect. Over time, some issues pile up. Sooner or later, one of the services will not be able to handle the load, and one of the commits will introduce a fatal bug, or a piece of hardware will break, or something entirely unexpected might happen. So how do we find this unexpected? Let me first elaborate on the term, the self-healing and where the term came from. So there are plenty of examples of resilient systems outside the software engineering environment. None of them is better than life itself. So we can take ourselves, humanity, as an example. We are a result of a very long experiment based on a small and incremental evolutionary improvements performed over millions of years. So we can learn a lot from the human body and apply this knowledge to our software and hardware. One of the fascinating abilities that we possess is the capacity to self-heal. Human body has an amazing capacity to heal itself. So since the smallest unit of the human body is the cell, throughout our lives, the cells inside our body are working to bring back the body to the state of equilibrium. So we can think of computer systems as the human body. It consists of cells of various types, and these types are the hardware and software. And the smaller they are, the better they have the capacity to recover from failures. Okay, so our self-healing system. So our self-healing system consists of two components. The first component is the monitoring component, and the second one is the automation component. So the monitoring component is the one that is responsible for the monitoring of the CPU, the server memory, the applications, and the performance and the availability of the automation part, or the automation component, is the RPA component, and it's responsible for automating the healing of the system. So it aims to listen the human interaction, and they are basically programmed bots, and they take the needed action whenever a failure is detected. The two components communicate together through the email triggering. So we have a listener over the emails that periodically check the email content and trigger the needed action according to the email content. So let me explain more the flow between the two systems. First, we have the monitoring component. The monitoring component will be monitoring the performance of the system. So when a problem or a failure is detected, it triggers an alert or sends out an email. Since you have a listener over the emails, the email will be parsed and the needed action will be taken by the bots, the automated bots, in order to bring back the system to the desired state. Okay, so based on the type of the issue captured by the monitoring solution, we have two types of actions that can be taken. The first one is the corrective action. So a corrective action is an action that is taken to restore the system to the designed state after a failure is detected. For example, if we have a database lock, over time, the database lock will close the system down. Or also, if you have any of the services down, in order to bring the system back up, we need to solve the locks or to start the service that is down. Another action that can be taken is a preventive action. So the idea behind a preventive action is to predict the problem that might happen in the future and act in a way in order to avoid this issue. An example for this, so if you have a very high disk space or high CPU usage, that might cause an issue in the future of causing the system to be down. So in order to avoid this problem to occur, we free up some disk space or also solve any high CPU usage. So the preventive action is taken in order to avoid a problem that might happen. A corrective already corrects an action in order to bring the system back to the design state. Okay, now we have a poll and we have three options. I just want to know your opinion whether which of the following might be a great advantage to the new system that we have now. Please choose either one, either A or B or C in order to check your response. Yes, so I think most of the people chose the early detection and handling, and definitely this is the highest and the most important advantage since we sense and we know the issue before it's sensed by the customer, before the customer operations are stopped or before any of their actions are being disturbed. So this is one of the advantages, although we have many others. As previously mentioned, we put the customer satisfaction at the heart of every action we do. So this is the motive behind the self-healing system. We want to make sure that the system availability and the product is easy to use for the customer. So the first and definitely the most important advantage is the early detection of the issue. So we become aware of the issue in the very early stages, and this saves a lot of time, and it prevents the operations of the customer to be stopped or disturbed. Also, time saving. So time saving, since they are all programmed bots, so there are a lot of less human interference with the system. So we save a lot of time, and the system is healed and saved quicker. Less human interference. So less human interference means that less agents who are going to be working on the issue, and this frees up the resources, frees the engineers to program the bots instead of do the routine work every day. And also, in addition to this, it decreases the agents to feel the issue and also to start opening the tickets regarding a down or something major that happens. Also less tickets. So by applying this concept, we will have less tickets, meaning that the tickets of the down and the repeated issues will be a lot less since they are not, since the actions are taken early, so no tickets will be opened for the issue. And that means that the tickets are going to be focused on the bugs and the new issues in the system. Also higher output accuracy. So since a human can do a lot of human mistakes, and that's normal and it happens. So since they are all programmed bots, but we will not have any. We'll have higher output accuracy, and will have less human mistakes that might happen during the bringing the system back to the normal state. So now we have another poll of 4 options or 5 options, and please choose the option that you think is the most attractive advantage to you. We'll have the options on the screen. Okay, so most of the people again chose the early detection, and definitely this is the one that is most attractive since none of the operations by the customer will be disturbed or stopped as a result of the issue that happened. So and definitely the previously mentioned advantages go hand in hand with the SRE concept. So the SRE concept is one of the core concepts that we're following in our department, and it's how Google run their production environment, promoting the high availability of the systems. So it's basically about programming the issues and taking and actions for the issues in a very programmed way, or in a way that would save the availability of the system and increase it for the customers. So how did we apply this concept in our work? So internally, we added sensors on all the layers and added our benchmarks and matrices in order to capture for any failures. That led to significant decrease in the number of errors and number of issues that we have. And definitely that led to fully automated system healing. So the system heals itself fully automatically. And also it reduced a lot of the routine work that we used to do every day. And hence the support system was fully and highly innovative. Externally, we provide this as a layer or as a solution for the customer upon the requests on the project. Okay, use cases. So how can we use this system practically? We have the technical use cases, and the technical use cases include automating the movement to the disaster recovery site, also doing any periodical performance checks on the system. We can do all the software installations, like for example, if you need to install a software on several servers, this can be done automatically and with a lot less time for this action to be taken. And we'll have the demo for this. The demo will explain this use case later. Also, any server checks or any server status checks, processing the emails and taking any action based on an email content in general is also one of the major use cases. Regarding the business use cases, so in the business scopes, there is a wide range of actions that can be taken. Some of the examples of the actions that can be taken: invoice processing, automating the reports, automating the payrolls, any customer service action, CV screening and the recruitments, and also for the IT, adding a new user or setting up the accounts for the new users also is one of the major and good use cases. And now we move to the statistics.
So, what we achieved so far. Ticket resolution time after automating issue handling is reduced by 53.76%. The number of system down raised tickets is reduced by 10%. System availability is increased by 30%. And from the above, we can see that this was our journey to perfection, the road to increase system availability and stability, till we reach our goal, the road to 99.99%. And now, for the demo. First, the monitoring solution. As we have monitoring sensors covering all the layers, these sensors display the scrape data on Grafana's dashboards. As you can see, here are our dashboards. Let's take a Windows dashboard as an example. From the following, we have the following panels. We have uptime, RAM, used memory, CPU load, disk use, free disk space, system exceptions, and system threads. So if we took a look at the used memory, we'll see that it's 96%, which is over the limit we configured in the alert rules file, as it exceeded the 95%. So it should send an email alert saying that it exceeded the rule we configured. So let's move to the email and see what happened. As we can see now, there is an alert mail fired saying that the used memory is more than 95% in a certain instance. That's how we configured it, so it's flexible to suit any case and any type of alert as we want it. So now let's check a database dashboard. As we can see here, the panels: availability, memory in megabyte, most elapsed time query, average CPU time, number of locks, and maximum wait time. So if we take a look at the number of locks panel, we'll see that it doesn't display anything now, but that's totally fine, as the way this panel works is this line at point 0 grows up to 1 or 2 depending on the number of locks in the database. So as long as there are no locks in the database, the panel will stay this way. So let's create a lock and see how this panel would change. Moving to the database to create the lock using a query, and then back to the dashboard to check the logs panel. Now we can see that the green line we talked about has moved to 1 in a certain time period. That's when the log took place. So I can know how many logs are there in the database, and I can also know when it took place. Okay, so now we have a log in the database. So then there should be an alert mail saying that the database has logs. So let's return back to the email to see if it sent one. As we can see here, there is a firing alert saying that there are database logs in a certain instance with the needed explanation we want. We configure the explanation or the summary and description in the email as what we need. Okay, so what will happen if the log faded? We return it back and we resolve the log. Then we looked back at the dashboard and we can see that the green line returned back from 1 to 0 again as the log faded. And if we took a closer look, we'll see that it turned to 0 at a certain time point. As we discussed before, in the dashboard, I can see how long the log existed and what time did it take. So now after the log faded, it should send a resolved mail. And as we can see, yes, it sent a mail saying that it's resolved. The database logs has been resolved in a certain instance. So now we are fully updated with our system's live state, if there is an alert or even if it's resolved. These alert mails are how the automation bots are fired to solve an issue. Now, moving to the automation bots to see how it's used to solve a repetitive issue. First, it takes the input data from a certain file. For example, here an Excel file. We take the data from the customer and insert it in the file, so the bot can retrieve it and use it in its workflow. Then, we run the exe file that contains the robot's configurations and workflow to begin its action to work on the issue. Then the bot now signs in to a certain website or a portal to simulate the reported issue using the input data to verify that this issue exists. Then, after the issue is verified, it extracts the related logs, then use a servlet to start the corrective action to fix the issue. Once the servlet has run successfully, an email is sent with each case's state and actions taken or to be done. As we can see in the email, the first case had no problem. Then the second case had a filenet issue and needs to be checked. For the third case, issue is solved by running the servlet. And that's how our superbots work. Now, let's see how our bots can install a program or a software. In this video, we'll show you the automation of SQL Server deployment. As we can see, the SQL Server Management Studio is not installed, so on running our bot, it starts to open the SQL Server file. Then, it chooses Download Media to download the ISO file. All these steps are taken by the bot itself after running it. I want to see now. See also both are both running in parallel. Meanwhile, we also see that the match studio is being loaded fast. After it's finished, look in the control panel and see that the Cool Management Studio is installed now. Go through programs and features, and here it is installed now successfully. And yeah, it's here. Finally, open it.
Okay, so we'll continue from this part. So after the software is being installed, we'll have these two terminals. These two terminals will be installing. Oh, so it's an automated bot. So the bot will be responsible for just downloading with the configuration of the SQL Server. And after that, if we check here, we will find that the SQL Server already exists. Yes, in the programs, we will find that we have the SQL Server here. And the SQL Management Studio is already installed. And this is how the whole process is automated without any human interference. So this is all the bot. This is what all the bot do. So this is the automated installation use case. Thank you. We're done. And let me know if you have any questions.
ميرولا. Thank you Mirola and Doha. Thank you for the webinar.
Okay, so thank you for your attention and thank you for listening. And maybe see you in another session.